Okay, so thank you for coming for the talk, ENS for the multi-chain world. And my name is Makoto, and I'm assuming everybody's here for the ENS session. Good. So let me start. So first of all, I hope everybody knows ENS. Who has ENS names? Great. And so maybe people knows now what that is. This things. Who has ENS card? Okay. Who doesn't? Okay. So you after this talk, you go to the booth and you get a card. And also the most asked question was, where's freaking lanyard? And it arrived. Yes, it arrived. So even if you have the card, you go back to the booth and you should have this shiny, purple lanyard. So that's the takeaway of this talk. But also, you guys are already ENS Pro, so you know that instead of giving you 0xBAC whatever address, ENS gives you like human readable name, which you can point to the address, so you can have that as a nick.is. And also ENS is NFT, but true usage is the number of integrations. We have over 557 integration from like MetaMask to like OpenSea to like Etherscan. So like everywhere you go in a mostly Ethereum ecosystem, you can, if you log in, you can see your ENS name as almost as a Web3 username. So hopefully this everybody already knows. And then today, the concept, title was ENS for the multi-chain world. And I want to start with a bit of misconception that ENS is just for Ethereum. And I mean Ethereum layer 1 mainnet. Then it's not actually true that if you go to somewhere like Aave is known that they go for like they deploy across multi-chain. And if you go to Aave's website, it has a market for different network. And if you pick, for example, Polygon, which is on its own proof of staking system, you can you connect as a Ethereum address. You can still see your ENS name as multicoin.is. And this is partly because most of the, I think probably like 80–90% of people who are here today still uses something called externally owned account, which is derived from your seed phrase, private key, public key pair. So, and one unique feature is like actually that's kind of cross-chain compatible by nature. So wherever like it's in different chains, you can actually see it. So that's one use case. It's already used in different EVM, so-called EVM, Ethereum virtual machine compatible chains. But now we are living in the world of 2023, and the people know something called account abstraction, or so-called all these contract wallet. That now it's not guaranteed that all these Ethereum addresses on your one chain doesn't necessarily exist, or you're gonna use the same on other chains. That we already have it supported since 2017 when we first launched that. We had something called multicoin address type that you can actually not only to be able to associate your Ethereum address to your address, you can pick whatever different coin types. Like you started, this is a kind of breakdown of the what other non-Ethereum address being associated. When we first designed, it was mainly for like Bitcoin addresses or non-EVM chains, but now, like we know the growing use case on all these EVM compatible chains. So, like I think if you go to Ethereum, our website, you can actually pick address to tie into different chains and coin types. So it's there, and then I could end the talk. This is it, and the people just go to the booth and get the lanyard. That could have been done, but then yeah, we can do better. So, but why? What part you need to be better? Probably you already guessed that storing the other chains information on Ethereum layer 1 is not exactly what you are envisioning when you say multi-chain, because most people try to nowadays kind of start avoiding Ethereum layer 1 for the good reason. Gas costs. Even our registration showed that like whenever there's a gas is too high on the I think bottom side of the chart, our Ethereum registration also goes down. So people try to avoid it. So we need a better solution. And again, quite often I get asked, what you guys do for layer 2? And we actually been working on this problem since 2020. And we have a couple of specifications which tackles it. One is called wildcard, which allows you to refer the name resolution of the subname to its parent. What it means is like if you go to MetaMask and if you type a.matokun.is, if that name doesn't exist, it can ask to its parents, which is matokun.is. That's a first specification, ENS IP10. Then in combination with, there's another one, EIP 368, secure off-chain data retrieval, aka CCIP-read. This actually allows you to, the URL1, so-called resolver contract, which usually in charge of storing your Ethereum address or your avatar text record on L1. To instead of returning address directly from on-chain, return the so-called gateway URL, which is just like a URL, and where that gateway is in charge of taking data somewhere. It could be, and we just call it off-chain. And one of the yeah, more, I don't know if some people understood with this complex looking diagram. Easier kind of similarity is just how NFT works in general. The NFT ownership is already on chain, but most of your JPEG metadata information isn't there. How do you retrieve? It's not rocket science. There's something called token URI, is part of the ERC-721 NFT standard, which just specifies the gateway, the URL, and the URL could point to another OpenSea database, or it could be IPFS decentralized file system. You get it. So what the previous specification enable is to treat ENS similar to how NFT works in general. And another thing interesting is, so I casually throw the name called Resolver. Resolver is one of the smart contract on Ethereum. And one unique thing is you can set per your name. So even though if I have a matokun.eth, quite often like most other dApps and the stuff, you kind of have to rely on some dApps to deploy to a certain chain, and you just use the chain they deployed. In your case, you can kind of create your own custom resolver to specify your preference of the storage place, and you can set per your name. So this, and then you can also, if you do it on your name, you can also do it for your subnames. So what this chart kind of graph is showing is like if you have, prime example, I'm going to explain CBID is like, CBID could issue all the subnames in Coinbase's storage, or like if you can send it to some other chains. So that's kind, and you can pick the storage of your choice. And yeah, well, I kind of run the solution, but why do you use example of these off-chain resolvers? Is most popular is one is CB.ID. This morning, I went to the venue like 15 minutes before the gate opens, and I saw, oh, I have to kill time, and then when I look at the side, and there's a Coinbase cafe. And I experienced like, oh yeah, I want to have a coffee. And they said, well, you have to first install the Coinbase wallet, and you have to, load these 5 dice so you can have a coffee. I love to be in the guinea pig, so even though it spent more than 30 minutes, I actually did everything, and I ordered a coffee using Coinbase. But amazing thing is, they show me that, all the show that like when I send from USDC from one chain to another, even though it was using I think Base, they're using Base chain, they were actually resolving the Ethereum ENS names, and they had it everywhere. That was beautiful. So it's already in use. Coinbase already, actually, sorry, that example is still using the off-chain resolve solution. So it's just using, in this one previous example, its storage is in their Coinbase database. And another example is Lens protocol. Lens has something called Lens profile, where it has .lens. So Stani, for example, the founder of Aave and the Lens protocol, he has Stani.lens. The data is stored on the Lens protocol on Polygon chain, but they integrated, extended so that you can resolve the Stani.lens with Stani.lens.xyz. And again, this is in a different chain. And one example is Slobo here. Yeah, okay. So issuing subnames is still a bit technical solution. So there are a couple of companies start popping up to provide this kind of solution as professional service. So it recently pulled together, said we're going to issue pull together .is subnames. And it's done by some external service like Nameston, which I think is run by one of our most active ENS DAO members. And that's good, but we can still do better. Okay, so what does that mean? I did it, so one of the thing is off-chain resolver is good, but it just means it's another trusted solution. What that means is the gateway service I explained in the diagram, that's actually the basically the, how to say, trusted solution. The gateway service is just another central point that like if that the gateway service is kind of compromised, attacker could actually change all the ECM address or your user subnames. So people could send all these ETH or precious NFT to the attacker's address. So there's so people have to trust the gateway as a service itself, which is good for something like Coinbase. Coinbase's main business is custodial wallet. They have very good security team, so you would trust a certain extent. But even them, they're trying to work on a more decentralized solution. So what we've been working for almost like 2 years, and still work in progress, is so-called L2 resolver, I also call trust minimized solution, which only works on so-called roll-ups, not any like side chain or other chains, but it works on roll-up chains such as optimistic rollup, Optimism, Arbitrum, or ZK rollup. All basic rollup chain has a common trait that they basically rely security on L1 by regularly kind of snapshotting their so-called state root, which is a hash of the entire L2 state, into Ethereum periodically. So that's the part of their chain security mechanism. And what we do is that the gateway, instead of just returning the data, you can actually return the data with a so-called storage proof on each L2, which allows all the L1 resolver smart contract to be able to verify that this data actually exists on this chain. So in the worst case scenario, when gateway service got compromised, the L1 resolver can simply reject, this is something dodgy, don't show it. And if you start moving to L2 resolver, this also has a benefit of the kind of easy to use resolver in general, that in the off-chain resolver solution, you either have to deploy your own gateway service, or you kind of have to trust someone like Nameston to not, secure the network. But with off-chain, L2 resolver, you don't necessarily have to trust it, because even if it gets compromised, you can invalidate. So when you set resolver to certain L2 resolver, you don't have to maintain this middleman web services. You can use any services which provide these similar things. And so that's the difference of off-chain resolver and the L2 resolver. And in terms of status, we have a proof of concept on Arbitrum, Starknet, and Optimism. And interestingly, so Linear, who just went main, I think yesterday or today, they actually were very keen on issuing subname on their chain using this trustless approach. And the amazing thing is we have a doc where it specifies how to do it. They just read it, they understood, and they all wrote the solution all by themselves. So they actually have the testnet solution on their Linear testnet. They already minted 400,000 names. So if you want to try out, go for it. But so not all teams as how to say, not genius, like great. Well, I can't say not as great. How to say? Yeah, I mean, it's great, but like you need a lot of resources if you want to build something from scratch. So many people ask, like, hey, I want to do something similar, but do you have something deployed on my chain or solution? So we need to provide canonical solution so that your team doesn't have to develop from scratch for every time. So but that is actually quite a long process of the. So what we decided is we kind of split the phase into 4 and try to deploy the most minimum viable version as early as possible. And the first step is actually to be able to just, so the final kind of our North Star is that all these things are quite complex, so we don't expect people to pick chain of your choice. We want someone like wallet or like exchanges or these players to issue subnames under their choice of network. So that's like issuing subnames and the stuff. That's a North Star. But currently, I think we want to target to technology, so someone who's willing to guinea pig, who can spend 30 minutes in front of a cafe, just trying to set everything. So what we're trying to do is, at least if you own your name, you can pick your choice of resolver to set the record, so that at least if you want to change your avatar record every now and then, it becomes gas almost free or gas cheap. So that's first step. We are working with a guy, I think there's a couple guys from a company called DM3. They are known as a company building the messaging service, but they also wanted to use ENS text records to store your preferred messaging protocol information, and they didn't want that to be gas expensive, so their kind of interests got aligned, and they went ahead and they started creating production code. It's again another great thing about open source, and if there's an open source and there's a document, there's someone smarter than us just already building and they're in the front running. I love that kind of front running. So like, even though I don't have any like fancy UI to interact, I just throw their basically GitHub repo. So there's some genius out here just like diving into this code. And if you have any questions, I'm happy to answer any of them, because I'm currently the one just guinea pig in this guinea pig. Okay, and for those people who wouldn't be interested in like looking into the GitHub code, one thing I wanted you to remember is ENS is not just for Ethereum, but ENS is a service powered by Ethereum. That's the only thing you screenshot, take photo, tweet, all that stuff. That's it. Thank you very much.